The Milky Way is not just a refrigerator magnet, presented by science at NASA. Every person on Earth lives inside a magnetic field. Springing from the core of our planet, lines of magnetic force wrap around the globe, deflecting compass needles, guiding pigeons, protecting us from cosmic rays and solar storms. Meanwhile, Earth moves through an even larger magnetic field, that of the Sun. Massive currents flowing beneath the solar surface give rise to a vast magnetic bubble that envelops every planet in the solar system. When NASA sent the Voyager probes to find the edge of the Sun's magnetic field, it took them nearly 40 years to get there. Turns out, that's nothing. Researchers working with data from the European Space Agency's Planck spacecraft have mapped the magnetic field of the entire galaxy. The Milky Way's magnetic field stretches across more than 100,000 light-years, says Charles Lawrence, the U.S. Planck project scientist at NASA's Jet Propulsion Laboratory, and Planck has done a magnificent job mapping its structure. In late 2013, Planck wrapped up a 4-year mission to study the cosmic microwave background radiation, the afterglow of the Big Bang. To study the cosmic microwave background, Planck had to unravel everything in the foreground, and that includes microwave emissions from the Milky Way. The Milky Way is made up not only of stars and planets, but also of gas clouds and dust grains floating between the stars. Dust is the key. Interstellar dust shines with a microwave light that is polarized by galactic magnetism. Tracing the polarization allows researchers to map the Milky Way's vast magnetic field. The Planck map, which resembles a giant fingerprint, is proof of a galactic dynamo at work. This dynamo operates in the interstellar medium that pervades our galaxy, says Katia Ferrière, a member of the Planck science team at the Institut de Recherche en Astrophysique et Planétologie in Toulouse, France. The motions of the interstellar gas, which is an electric conductor, generate electric currents, which in turn generate magnetic fields. Similar currents move through the molten core of Earth and in the interior of the Sun, except this is on a vastly larger scale. The main motion of interstellar gas in the Milky Way is rotation about the galactic center, continues Ferrière. This rotation not only generates the magnetic field, but also stretches it in a circular direction, wrapping magnetic field lines around the galactic core. If we could see our galaxy from the top down, she says, the magnetic field would have a spiral shape. Because Planck sees the Milky Way edge-on, however, the spiral field appears to line up parallel to the galactic plane. There are also many graceful arches and loops that trace the shells of nearby supernova explosions. Mapping these details is important. For one thing, notes Ferrière, it helps us understand very high-energy cosmic rays. These mysterious particles are deflected by the Milky Way's magnetic field. Tracing them back to their point of origin requires knowing that field's morphology. Also, adds Lawrence, magnetic fields have a strong effect on how clouds of gas collapse to form stars. So this is telling us a lot about star formation, too. Work in this area is not done. Later this year, the Planck team plans to release a new map based not on dust, but rather on free electrons spiraling through the magnetic field. This could reveal new structures in heretofore unexplored regions of the galaxy. Says Lawrence, we still have some fingerprinting to do. For more news about the Milky Way's magnetic field and other results from Planck, stay tuned to science.nasa.gov.